So hopefully you're having some fun with these. Oops, here it goes. All right, I'm going to scroll up. First thing I'm going to do is I'm going to rewrite this to give myself a little more room. So secant squared theta minus 1 over secant squared theta. And then it's going to equal sine squared theta. Right? That's what we're trying to get to have happen. Now, if you're wondering about theta, do I have to keep writing the theta? Yeah, you have to keep writing it. Okay, because it's a function, right? It's got to be of something. So we've got to have that theta there. Or it could be an x or some other angle, but it has to be there. Okay, now a little tip here. So tip of the day, tip of the video here. You can't make a sine into a cosine. You cannot. Well, that's, okay, my tip isn't working very well here. Okay, can't make sine into cosine. And vice versa. You can't make a cosine into a sine. You can make sine squared, you know, and I just broke my rule that I said that should be sine x and cosine x. You can make cosine squared x into, or sine squared x into cosine squared x. So if it's squared, if sine squared and cosine are squared, then you can work with that, okay, because we can use the Pythagorean identity. But if it's just a sine x and you're trying to turn it into a cosine x, no, you can't do that, okay? So remember that. And then we'll go over here and keep our idea list going. So how am I going to work with this? Now, I kind of have a plan of how I want to do this problem, but you're watching it, you know, and so you might not have a plan yet, and they're kind of new. So you see this secant squared. Now, if you're looking at your, you know, fundamental identities, you're like, oh, I see a secant squared. It relates to tangent squared, which is great, and that might be a way you can go. Maybe you want to go that way, and that might be a good way to go. I'm not going to go that way, but it could be a very good way to do the problem. I see how that could work. The reason I'm not going to go that way is I don't have a tangent squared on the right-hand side. I have a sine squared. But if you're like, no, I really want to use that tangent squared idea, you can do that. It'll work, okay? But I'm going to do it a different way. Okay, so I'm going to use what I know about fractions a little bit. So I have one term here in the denominator, right? So I'm going to rewrite my expression on the left here as secant squared theta over secant squared theta minus 1 over secant squared theta. Okay, that's just how I'm deciding to do it. Now, some of you out there, I hope you're thinking, hey, tangent squared theta is going to work. I think you would have a lovely alternate way of doing this problem. I could probably do this problem more ways, and I don't want to spend, you know, a bunch of time just redoing the same problem, but you could. Okay, so now secant squared over secant squared, that's just 1. But what do I know about 1 over secant squared theta? So I know that it's cosine squared theta. Now sometimes that's confusing for students because they're like, hey, wait a minute, you know, cosine theta is equal to 1 over secant theta, but that's not what you have, right? Yeah, but I'm allowed to square both sides. So if I did, I'd have cosine squared theta equals 1 over secant theta squared, like if I'm squaring both sides. And then I'd have cosine squared theta equals 1 squared, which is just 1, over secant squared theta. So you don't have to write all this work out. I'm just showing you that I can do what I did. Okay, and then you get cosine squared theta equals 1 over secant squared theta. So sometimes students are like, hey, wait a minute, our identity doesn't have a squared in it. How do you get to do that? And this is why. Okay, so then do I know something about 1 minus cosine squared theta? I do. It's one of those alternate forms. We know that sine squared theta, oh, I looked up the square. Sine squared theta equals 1 minus cosine squared theta. And remember that comes from, here goes my stuff, it comes from the Pythagorean identity, sine squared plus cosine squared theta equals 1. So just subtract the cosine squared and you get it. All right, so this is sine squared theta. And that's what we wanted, right? Sine squared theta. Okay, we're done. All right.